you. Well, hello, everyone, and thank you so much for joining us. My name is Jackie Fitterman, and I am the CEO of Cignal. And with me today is my husband and CTO, Eric Fitterman. So before starting Cignal, I was working at the FBI as an intelligence analyst. In fact, that's where I met Eric. He was working there along with me after 9/11 as a special agent on the same squad, in fact, the same desk, the cyber squad. And now we have Cignal. And what Cignal allows us to do is to continue to support the very important mission of protecting our country and its people. And we've been supporting the Homeland Security enterprise through our software product, which is called Cignal Engine. And Cignal Engine was designed to address several key challenges. There we go. Some of these challenges are threats that are constantly evolving, data sets that are very large and very difficult to collect, as well as data sets that are very challenging to share due to privacy and security restrictions. So to solve these problems, we created Cignal Engine, which is a synthetic data environment to test AI vision models before they're operationally deployed. Now, with Cignal Engine, we are able to simulate current or future threat objects using a variety of techniques. And beyond that, we are also able to share this data more readily because we are not exposing any privacy or security information. Now, outside of Homeland Security, we are starting to explore additional applications for Cignal Engine in spaces such as healthcare and non-destructive testing. Go back one there. Some of the features that we have available for Cignal Engine and some of the tools, AI developers and AI testers are able to utilize these. Some of them are very unique, and Eric is actually going to walk you through some of them in our demo video.
Okay. Cignal Engine is a containerized data generation environment that's designed for security, privacy, and safety. Cignal Engine is able to generate 2D or 3D image data in a variety of different modalities. And right now we support X-ray, X-ray CT, and we just completed some prototypes for millimeter wave, including some concepts for 4D video, which you'll see here in a moment. Cignal Engine supports the ability to perturb the shape features of objects as well as the material texture to give a lot of diversity of data in the data sets that it's able to generate. And we're able to combine these features with a very powerful physics engine to create an unlimited stream of test cases and test data. And what this allows us to do is to generate test cases that may be too unique or challenging or dangerous to recreate in the real world. Using Cignal Studio, we're able to prototype novel or emerging threats like 3D printed weapons with our integrated 3D printer that's built into Cignal Engine. And lastly, we're very focused on AI workflows. So all the image data that Cignal Engine creates come already labeled. And we're also working on a Python package called PySignal that will give AI developers and testers the ability to directly access the engine and its capabilities directly from Python code. All right, so in terms of differentiators, Cignal Engine is patented. As I mentioned, it's multimodal and it's highly compressive for data efficiency. As I mentioned, it's containerized, so it can be deployed anywhere for security reasons, privacy too. In addition to some of the AI integrations I mentioned, we also are working on things like a capability in Cignal Engine so we can directly write to tensor objects instead of having to save images or video out to disk or over slower I/O channels.
It down. I will keep this very brief, but we are very grateful to have this opportunity with SVIP. It's really allowed us to continue to support the mission of protecting our country, and we're just really grateful to have the support of Melissa O and the entire SVIP team. And so with that, I can wrap it up, but If you would like, we are available in the expo space upstairs. Come and visit us today or tomorrow. If you have any issues regarding data challenges, we are more than happy to talk with you. Thank you very much.
Thank you very much. Great presentation, and I know you have a long working relationship with us as well as the folks at the Transportation Security Lab. Obviously, from the testing standpoint, we see real opportunities with synthetic data. It's costly, it's dangerous, it's time-consuming to develop and create real bags using real threats. So obviously, opportunities where we can create synthetic images to improve the testing process and really make the algorithms more robust. I think that's ideal. New threats, you talked about generating new threats. How much information do you really need in order to generate new threats? Are you looking for physical properties? Are you looking for just parameters of texture? Are you looking strictly at Z effectiveness? What's most relevant as you develop those new threats in your library?
So I think one example maybe of what you're talking about is when we were showing the what we call infinite bottles. So some threat items, we can, like I was saying, perturb the shape features and material of those objects. And so that's one way we address that, because like bottles are a great example. And that was one of the things that kind of blew our minds when we first started doing this, was the interest in bottles. So that's one way we can do that. Just also to explain maybe a little bit about the Cignal engine pipeline. The way we look at our pipeline, it's not one component. There's not like, it's not all generative. We have an asset component that uses generative and procedural techniques to create new objects. Then we have a rendering pipeline, and then a reinforcement learning stage. So I'm explaining that because we do have different techniques to be able to create those different threat item embodiments and materials, and the whole idea is to be able to automate that so that the engine really drives the development and curation of those data sets, so a person doesn't have to do that. Plus, especially with generative techniques, if you want to call it imagination, they can be as imaginative as an adversary. And so, we can have a generative AI essentially crank out different versions of different threat items or different objects and different materials. And it's just a lot more efficient and may actually come up with some unusual things that we haven't imagined. So, yeah.
Thanks for a great presentation. What kind of testing do you do of the Cignal engine, either standalone or in the context of a user, right, using the system to ensure that there's no residual bias?
Yeah, that's a really great question and very timely. We have just wrapped up our phase 3 with SVIP. Part of our phase 3 did involve some validation of our engine with a third party. So a government support team went through and basically was able to ingest and run engine in their own environment and then see how that data compared to real data. So we did have some third-party testing, but we do our own internal testing too, because we want to make sure that we're not building in something that shouldn't be there in the first place. So our engineering team, as they develop, they will make sure that what we've built actually is it's not biased, it's relevant, and it's as close to real data as we can get. So we do internal testing, we have sent it out to third-party testing, and if we proceed on to a phase 4, it will get even more testing outside of us. So we look forward to that.
And I'll follow up final question of, so I think you've obviously had quite a bit of work done in this kind of DHS, SVIP, CBP world, as the not DHS, CBP, SVIP person. I think you probably could have hammered home the problem you're solving a little bit more on the front end. I could have used that for sure. I'm there now, and I'm with you now. But can you tell me a little bit more about, are you thinking about going to the systems integrators and trying to make sure that they all have access to this as well? Because that's obviously a huge part of the technology dev is happening both internally but also externally with the systems integrator community.
Yeah, one of the main things that we're working on now is being more of a collaborator with our peers. So those not only developing AI algorithms and those who are testing, but those who are developing the machines themselves, the scanners, either within this environment, within healthcare. So we do not want to be a systems integrator. We are way too small for that. But we do want to be able to leverage that system and make sure that we're providing something that our customers would need and that it can actually get out there and become operational. So collaboration is a big part of what we're doing, and we absolutely want to work with as many folks as possible to not only kick the tires, but to make sure that we're best meeting every customer's needs.
Thank you so much.
Thank you.